In this video, we're going to have a look at how we can solve some linear equations simultaneously by using the elimination method. So, just a recap that linear equations have two variables. We're used to using x and y because we use the Cartesian plane quite often, or the number plane quite often, but we could have any other pair of pronumerals there. So for instance, we have y equals 2x minus 3 is a linear function. And this equation has an infinite number of solutions. For instance, we can have x equals 0, so 2 lots of 0 is 0, take away 3 is negative 3. So we have the solution 0, negative 3. When x is 12, 2 lots of 12 is 24, take away 3 is 21. And also when x is a half, we get y equals negative 2. So they're just three solutions. There is actually an infinite number there, but we're going to have a look at when we have a second linear function, what happens then. So a second one, if it's not parallel to the first one, then those two functions will have one point where those lines would actually intersect. Now that's known as the point of intersection. So there will only be one x value and one y value as the solution to a pair of simultaneous equations. So we're going to have a look at how we solve these equations simultaneously, and as I said, we're going to focus on the elimination method. We're going to use this method when neither of the equations are written as x equals or y equals, or as I said, if there's different pronumerals there, whether it's an a equals or an m equals. So we're going to use the elimination method when they're not written in that form. So for instance, our first example, we've got 2x minus y equals 3 and 4x minus y equals 7. So to solve these simultaneously, the first thing we're going to do is label the equations. So equation 1, our first one here, and equation 2, our second one. And the reason we do that is so that when we refer to either of them, we know which one we're talking about. So once we've labelled them, we then want to have a look at our coefficients of our x values and also our y values. So what we mean by our coefficients is these numbers in front of the x values here and the numbers in front of the y values here. So remember, that's a 1 hiding in there, 1 hiding in there. So if we have a look at their x values, we've got a coefficient of 2 and a coefficient of 4. Now they're different. But if we then go and have a look at our y values, we've got a negative 1 and also a negative 1. So they're the same, including the sign. So they're both negative 1s. So what that means is if we want to eliminate those y values, then what we have to do is we need to subtract those two equations. Because negative 1 take away negative 1 is the same as negative 1 plus 1, which gives us 0. Which means our y values will eliminate. So to do that, we need to write down what we're doing. So we're taking equation 2 and subtracting equation 1. So why am I not doing it the other way around, 1 minus 2? Well, if I have a look here, I've got 4x is bigger than 2x, and I've got 7 bigger than 3. So if I subtract that way, then I'm going to end up with some positive values, which can be an advantage. So equation 2, take away equation 1. So I've got 4x take away 2x, that'll be 2x. Negative 1 take away negative 1y gives us 0, and 7 take away 3 is 4. So we end up with this linear one-step equation here, which you should by now know how to solve those. So divide each of those by 2, and we get x equals 2. But we haven't finished yet because all we've done is found the x value that these two linear functions have in common. So what we now need to do is find the y value that they've got in common. To do that, we're going to sub this x value, x equals 2, into one of these equations. Does it matter which one? No. But what I'll do is I've written down here, I'm going to substitute in x equals 2 into equation 1. So wherever I see this x value, I'm going to replace it with 2. So 2 lots of 2. So 2 lots of 2, take away y equals 3. simplify that. So we get 4, take away y is 3, and when I subtract 4 from both sides, I get negative y equals negative 1, and divide both sides by negative 1, and we'll find that y equals 1. So I've got my x value, I've got my y value, so let's write a concluding statement. Therefore, the solutions are x equals 2 and y equals 1 for those simultaneous equations. So there's one example. Let's go and have a look at another example. This time we're going to find the point of intersection of these two lines. So we've got the line which is a linear function, 5x plus 2y equals negative 14, and we've got negative 5x minus 4y equals 8. So again, our first step is to label each of the lines. So equation 1 and equation 2. And I've written them. You'll notice the x's are underneath each other, the y's, and our constants written there. So let's look at our coefficients. The coefficients of our x values are 5 and negative 5. Our coefficients of our y values are 2 and negative 4. They're not the same. The x value ones are the same. So we've looked at the coefficients. Our x values are the same, but you'll notice they're different signs. So positive 5 and negative 5. So if I want to eliminate those x values, then because they're opposite signs, I'm going to add the two equations together. Alright, so when they're the opposite signs, then we're going to add the equations so that these x values will eliminate. So let's write down what we're doing. We're going to take equation 2 and add it with equation 1. So 5x plus negative 5x. That's 0x, which is just 0. They eliminate. 2y plus negative 4y is negative 2y. And negative 14 plus 8 is negative 6. So we've got negative 2y equals negative 6 when we add these two linear functions together, remembering they eliminate. Now, again, one-step equation, divide both sides by negative 2, and we get y equals 3. But remember, all we've done is found the y value that those two linear functions will have in common. So let's go and find our x value. So I'll just divide my page here so that we've got all our working on the same screen. We're going to substitute this y value into one of these functions. Does it matter? No. But what I might do is substitute it into equation 1 because I don't have a negative y value there. Just want to try and avoid making mistakes, especially with negatives. So let's replace our y value with this 3. So I'm going to have 5x plus 2 lots of 3 equals negative 14. 2 lots of 3 is 6, so I'm going to end up with a two-step equation, and I'm not going to go through too much of the process. Subtract 6 from both sides. We get 5x equals negative 20, divide both sides by 5, and we get x equals negative 4. So you should be able to do that. Yes, I have skipped some working out there, all right, but by this stage, if you're solving simultaneous equations, you should be able to solve some two-step equations. All right, so let's finish it off. We want the point of intersection. So our concluding statement is the point of intersection is negative 4, 3. So remembering when we're doing a point where, pair of parentheses there, or brackets if you like to call them, separated by a comma. X value first, then our y value. And we've now finished that example. But what we'll do is we'll have a look at one more. We're going to solve these two equations just to show you that we don't always have x's and y's. And I've already labelled the equations here just to quicken this up a little bit. So let's check the coefficients. 3a and 2a, they're not the same. 2b and negative 4b, they're not the same either. So how do we eliminate them? Well, because none of them are the same, what we will probably do here is have a look at, can we change one of these, or maybe even both of them, to be the same? Or can we change one or both of these to be the same? So what I'm going to do is I'm going to take equation 1, this first one here, and if I double this multiplied by 2, I get a 4. So I can easily change this equation by doubling everything, making everything twice as big, and that way we will have a coefficient there that'll be the same as that one. So when I do that, 2 lots of 3a is 6a, 2 lots of 2b is 4b, and 2 lots of 0 is still 0. Now this time I've labelled it equation 3. Okay, so what I'm going to do is I'm going to now be working with these two equations because I've now got some coefficients the same, even though they're opposite signs. So what I'll do is I'll just get rid of equation 1, so it's just not so confusing. Yes, it's a little bit easier for me, and you would just try and ignore that equation up there. All right, so coefficients of the b's are the same, but they are opposite signs. So to eliminate them, we have to add them. I'm going to do, okay, I've said that, eliminate them. We're going to add these equations. So equation 3 plus equation 2, and that way negative 4 plus positive 4 will be 0, so they eliminate. So 2a plus 6a is 8a, 16 plus 0 is 0. Now, one-step equation, divide both sides by 8, and we get a equals 2. Now that we've found our a value, then let's substitute it back into one of the equations. So I divide my page, I'm going to do it over here, but I'm going to put equation 1 back up there so we can see, because I might be able to substitute it into there. So does it matter which one? No, I can even substitute it into this one, equation 3. But what I'll probably find is it's easier to substitute it into one of the original ones. So let's sub equation, a equals 2 into equation 1. So that way I'm working with a positive b value there instead of a negative b value. So 3 lots of 2, because my a value was 2, plus 2b equals 0. So 3 lots of 2 plus 2b equals 0. And I'm going to go and solve that, subtract 6 from both sides, divide both sides by 2, and I get b equals negative 3. So again, I've skipped out a couple of steps there, right, which you can or should put in, but just so you can see the process, I've just gone straight to the solution there. And again, concluding statement, therefore the solution is a equals 2 and b equals negative 3. So I hope you found those examples and my explanation helpful. So that's solving linear simultaneous equations and using the elimination method. Okay, so thanks for watching, and I hope you found it useful.